Alright folks, in this video I want to walk you through how to implement the reference architecture's hybrid hub and spoke VNet implementation. Now you see on this diagram, we will be creating a hub VNet. In this hub VNet, we will have a shared resource. In fact, we will be deploying a Linux box whose job is to route traffic. And the way this is going to operate is the following. We will have an on-premise network. In the demonstration that we'll be doing, the on-premise network will also be a VNet. So this will be a VPN gateway connecting to a VPN gateway in the hub VNet. The hub VNet will have a single Linux box that serves as a router. Okay. And the purpose of that is so that on-prem machines can use that NVA, network virtual appliance, to get traffic out to these other peered network. We will also be creating two spoke VNet using peering. So for each of the spoke network, there's no need to deploy a gateway subnet nor a virtual network gateway. Now we will be paying extra attention on the way we configure the VNet peering, including the options that we must specify. Additionally, we will also look at the user-defined routes that will direct traffic from the gateway network to these peered VNet. We will be using AZBB command line utility to provision the set of resources. You'll find the link to that code is available on GitHub. You can click on deploy the solution and find the GitHub URL. The GitHub URL is under github.com/mspmp reference architectures. Now to use AZBB, I've already cloned the source code from GitHub. You must have Azure CLI 2.0 on the machines, and you'll also need to use node npm package manager to install these building blocks. And also make sure your AZ session has been properly logged in, and you go to the Windows device approval portal to grant permission to your AZ session. When you clone this repo, the first file we'll be working with is called the onprem.json. The onprem.json deploys a virtual network. Again, this is not a complete standard ARM template. This is actually a AZBB template. So there's a simplified number of properties. This will create a virtual network occupying 192.168. This will be our makeshift on-prem network. Has two subnets, no surprises there. A virtual machine using the on-prem VNet in the management subnet, and we will also be creating a virtual network gateway. Now that virtual network gateway will be created in this on-prem network. So this is all pretty straight up deployment. This template will take about 40 minutes to deploy, and I've configured that already. And you can see that in my portal. Okay. The on-prem deploys this VPN gateway on the on-prem VNet. Okay, so you can see it's on the 192.168.1 network. Now I just want to quickly look at the gateway. Okay. Now, when you are deploying this, keep in mind if there is a updating label here, the gateway is not completely provisioned, so don't try to configure while it says updating. Okay, so the on-prem JSON, that's just that. Nothing special here. That's the end of on-prem. We will also be deploying the hub VNet because these are the two time-consuming resources. Because we are running the hub VNet after we create the on-prem, so let's review the syntax here. Okay. Where we'll be building out a virtual network called hub VNet with 3 subnets defined. Okay, so let's hide that. And the next resource is virtual machine. Again, this virtual machine will sit in the hub VNet as the jump box. We'll also provision a virtual network gateway in the hub network. Now this section is something that we did not create when we created the on-prem, because in order to create a connection, you must have a pair of these VPN gateways. So therefore, when we deploy this hub VNet, we should have both gateway up and running. And this will create a connection from hub to the on-prem, and it uses a shared key. So this is the local, there's the remote gateway, and this is the hub gateway. And this is the other side of the connection. You'll see that they are almost exactly the same, okay, except the order being different. All right. So when you deploy the hub VNet, you will see those two connections. All right, so I'm navigating to the on-prem VPN gateway. Now, if you didn't use the template to create the connections, you can go to the portal and click on Add, and this will create a on-prem to hub, S2S. So I'm going to select the hub VPN gateway and just create a shared key. Okay. Deploy that connection. Now, while waiting for that to complete, I'll move back to the other gateway, which is my hub gateway, and create the other connection. And this other second gateway will be the on-prem. Now, so far we have completed the two resources, and referring back to the Azure documentation, this is the part that we have implemented so far. We have the two network. This is being the on-prem. Instead of express route, we're using site to site, so the gateway are connected at this point. But these are only standard connection at the moment, so it allows on-prem network to access other networks in here, and that's what we've accomplished so far. Next, we will be creating these additional peering hub network. And finally, we will deploy an MVA here to route traffic from on-prem to bespoke. So back to Visual Studio, you'll find the spoke1.json. We create a VNet for spoke 1. Now, this time we are creating a VNet peering Now the part to pay attention to is that if you're planning on cross-spoke connectivity, you want to make sure you understand all three options. Assuming that spoke 1 is creating the peering to the hub. Now we want to make sure that we will be using the remote gateways. So from spoke 1, we will be sending traffic using the remote gateway. We need this because this remote gateway will also relay traffic to spoke 2. So in other words, when we create a spoke 2 VNet, we will also tell it to use remote gateway and allow forwarded traffic. Now the allow forwarded traffic is used primarily so that spoke 2 can send traffic through this gateway into spoke 1. Because spoke 1 and 2 do not actually have their own gateway, and we're not going to be allowing gateway traffic from, obviously, a VNet that doesn't have a gateway subnet. So we'll make sure that allow gateway transit is set to false. So this will be the peering from spoke 1 to the hub. Now in spoke 2.json, you'll see almost an identical setup with respect to the virtual network peering. Now here's the command line that uses azbb, specifying the subscription, the resource group of which we are deploying the VNet. So this was the command line that I ran to create the virtual network gateway. The location being ECUS on-prem.json. So this is how I created the on-prem. Now this is the command line that creates the hub VNet. Okay. The -p points to the JSON file that we want to deploy. So now we're ready to deploy the spoke 1 network. So this will be going to the spoke 1 VNet resource group in ECUS 2. Because I don't have to wait until that finishes, I will also do the spoke 2. And in a few minutes, they should be done. All right, so at this moment, the 2 virtual network has been created, spoke 1 VNet. We can review the peering setting, and you can see that from the spoke 1 to the hub, peering has been initiated. Now it's waiting for the hub network to establish peering to spoke 1 and spoke 2 respectively. Now, to create those resources, this is the hub VNet hub VNet peering.json. So this is the document that will create the hub to the spoke. Okay, we ran this earlier. Okay. And actually, no, we didn't run this earlier. We're going to be running this right now to add the 2 virtual network peering. Now, again, let's make sure that we configure these. Okay. Our hub VNet is the gateway VNet, so the allow gateway transit has to be true, and we will also allow forwarded traffic to go through this peering connection. Okay. And this is the hub to the spoke 2 peer, and we'll be deploying this hub VNet peering.json again. I'm going to bring this up. Now here's the azbb command that deploys the hub VNet RG, the file hub VNet peering.json. All right, after the template deployment succeeded, going back to the hub VNet peering section, now I can see the template deployed to peering connections, and instead of initiated, it's now connected to the peer spoke 1 and spoke 2. Now click on each one of these, we'll confirm the peering settings, allow forwarded traffic, allow gateway transit on the hub VNet to hub 1 and hub 2. All right, now the two spoke network along with their VM has been deployed. The peerings between the hub and spokes are done. The site-to-site VPN is working as well. Now we're going to do some quick testing, and also want to be 100% clear on at what point we are in this overall design. Now back to our original diagram. In this design, our on-prem network VM, which sits on 192.168.1.132. So this VM, through the site-to-site VPN, will be able to access each peered network's resources. We have not advertised any routes nor deployed the network virtual appliance. So as stands right now, the on-prem VM has direct access to the peered spoke network. All right, so I've made a connection to JBVM1. So this will be the VM on-prem. Okay. We can use the test connection to see if we can access the spoke 1 VM on RDP port. So that seems to be okay. And we'll look at the VM in the peered network. However, in this setup, the spoke do not connect or communicate with each other. So we can give this a try. I'm going to remote desktop to the VM in spoke 1. And I'll try to make a connection. All right, so we're logging on. Now keep in mind, at this moment we are on the VM on the spoke 1 network. Now we have no access to the 10.2.068, which is a VM on spoke 2. Okay. It's just going to hang there, and it will take a while, and eventually come up as not accessible. Now on the other hand, we can try to access, so this didn't work as expected. All right. Now we can try, however, 192. Well, that means I'll be connecting to the on-prem VM, which will probably kick myself out. Let me go ahead and pull the IP for the hub VM. See if we can get to that hub VM. So my hub VM has a private IP address only at 10.0.0.68. So that's the IP address I would try to connect to. All right, so you can see that I have access to the VM in the hub. Now, because I'm remote desktop from my on-prem VM to begin with. So I know that I can get back. I just don't want to kick myself off of the RDP session. Okay. So once this connection is established, this VM is the hub VM 10.0.0.68. All right. Now, as a server in the hub, at the moment it's accessible from all the spoke as well as the on-prem network. So from the hub VM, I'm able to successfully access my on-prem VM. There should be no surprise that connecting to both spoke should also be fine. 10.1.0.68. So the test succeeded. All right, so let's recap that given the setup, the jump box using the red arrow has direct access. That's the hub VM. The blue arrow is traffic originated from the on-premise network, is able to access the jump box, is able to access the spoke 1 VM and spoke 2 VM. The green line represents the jump box in the spoke. Jump box in the spoke can access the hub resources, can also access on-prem VMs, but it does not have access across the spoke. Now, to make this connectivity so that spoke can communicate with each other, we will need to continue and deploy a network virtual appliance. The job for that network virtual appliance is to allow traffic coming from the spoke So in other words, the jump box in spoke 1 will forward the traffic to the gateway subnet, where there is a virtual network gateway, where a route will be recognized to forward the packets to the network virtual appliance. Now this network virtual appliance will then subsequently route traffic from the hub network to the spoke 2, and vice versa. So all the traffic that originates from spoke 2 will hit the gateway. The gateway will then forward the traffic to NVA, and the NVA will be able to deliver the packets to jump box 1. So that's going to be the next template that we'll deploy. We'll create this network virtual appliance. It's going to be a Linux box that just simply enables IP forwarding. Now within that box, within the subnet that box occupies, we'll be advertising a couple of routes. So let's take a look at how that template is declared. So the file we're looking for is the hub nva.json. Now in hub.nva hub nva.json, we're going to create a Linux box. Okay. Now this Linux box contains a single NIC card in the DMZ subnet. We're going to enable IP forwarding. And there is a bash configuration that configures the IP forwarding parameters. You can take a look. It's a very simple couple of lines of code. Okay. All right, so just make sure IP version 4 forward equal 1 to the setting clause. Okay, so assuming that this NVA machine comes up properly, we will be advertising a route. Now this route specifies any address destined to the local hub VNet. We will route it locally. So the next hop is VNet local, which means we don't have to deliver them traffic to anywhere else. The network which this gateway subnet resides will be able to route traffic directly without further assistance. The second route, this is the pink arrow that you saw earlier, so that any traffic destined any traffic that's destined to a network that does not have a routing entry, so this will be the default routing for the virtual network gateway when the destination network is unknown. So in this case, spoke 2 will be unknown to spoke 1, and the next hop is 10.0.0.36. Now that 10.0.0.36 is the static IP or reserved IP for this Linux box that will be forwarding traffic. All right, so let's go ahead and push out this template.